Have you ever looked up at that faint, milky smear across the night sky and felt small? Like you're standing on the edge of a vast, silent ocean you don't have a map for? For most of human history, that's all the Milky Way was: a myth, a river of milk, a path for ghosts. But beneath that beautiful glowing fog lies a reality far more chaotic and mind-bending than we ever imagined. We aren't just living in a static collection of stars. We are passengers on a 13-billion-year-old cosmic juggernaut, a galaxy that eats its neighbors to grow. A place where stars are routinely slingshotted into the void at millions of miles per hour, and where an invisible, ghostly scaffolding called dark matter is the only thing keeping us from flying apart into the dark. Tonight, we aren't just stargazing. We are peeling back the layers of our home. From the screaming fast orbits of the galactic core to the ancient fossil stars in the halo, this is the definitive biography of the Milky Way. Welcome to the journey of a lifetime. Before we drift into the deepest secrets of our cosmic neighborhood, do me a favor, hit that subscribe button and join our community of space explorers. It helps us keep the lights on here at the edge of the universe. And while you're at it, drop a comment below. Where on Earth are you watching this from tonight? I love seeing how far our home, the Milky Way, feels like a solid, permanent fixture of the universe, a grand, swirling city of light that's always been there. But if you could rewind the clock 13 billion years, you wouldn't see this elegant spiral at all. Instead, you'd find a chaotic, wild landscape of gas and dark matter. You see, the Milky Way isn't a natural single object. It's more like a cosmic Frankenstein's monster, stitched together from the wreckage of dozens of smaller galaxies that it ate to survive. Over billions of years, our galaxy has acted as a gravitational predator, drawing in smaller dwarf galaxies, unraveling them with tidal forces, and scattering their stars across its own disk like trophies. This cannibalistic nature is actually written into the very DNA of the stars we see tonight. When astronomers look at the chemical fingerprints of the stars in our neighborhood, they find some that just don't belong. Every star carries a unique signature, a pattern of elements like iron or calcium imprinted at the moment of its birth. Some stars in our halo are almost pure hydrogen and helium, containing virtually no heavy metals. These are the elder spirits of the galaxy, born shortly after the Big Bang in tiny, primordial worlds that were eventually swallowed by the Milky Way. By tracing these chemical signatures, we've realized that the Milky Way has consumed dozens of these companions, including a major merger known as the Guan-Celadus event, which completely reshaped our early structure. Even now, this process hasn't stopped. If you could look deep into the southern sky with gravity vision, you'd see a small galaxy called the Sagittarius dwarf being ripped apart right now, its stars being smeared into long, ghostly ribbons that wrap around our galactic disk. These stellar streams are the scars of past meals, thin ribbons of light that act as a map of the Milky Way's violent history. It's a humbling thought, isn't it? That the very ground we stand on and the stars we wish upon are part of a structure built from the ruins of 1,000 smaller worlds. We aren't living in a pristine sanctuary. We're living in a survivor. But why does this matter to us, sitting here on a tiny rock in the suburbs? Because this history of collision is what gave the Milky Way its shape. Most of the stars in our galaxy orbit the center in a nice, orderly fashion like cars on a racetrack. But every now and then, we find rebel stars in the outer halo that are orbiting backward. These stars are the survivors of those ancient mergers, still moving with the momentum of the home they lost billions of years ago. They are quiet reminders that the galaxy carries its memories in its motion, preserving the stories of cosmic encounters in the slow, patient turning of stars against the stream. As we look toward the future, we realize the Milky Way story is far from over. We are currently on a high-speed collision course with our neighbor, the Andromeda galaxy. In about 4.5 billion years, these two great spirals will meet in a dance that will change everything. It won't be a violent crash. Stars are so far apart they'll likely never touch, but their gravity will warp and stretch them into long, elegant arcs of light until they eventually merge into a single, massive system. We are part of an unfinished story, a galaxy that is still growing, still breathing, and still learning what it will eventually become. Family stretches. Imagine for a second that the entire history of our solar system is a single day. In that timeline, human civilization has existed for less than a blink, and even the reign of the dinosaurs was just a brief afternoon. This perspective shift is necessary because when we talk about the motion of our home, we are dealing with a great galactic year, the time it takes for our sun to complete just one single loop around the center of the Milky Way. It's a staggering 225 to 250 million Earth years long. To put that in perspective, in all of its 4.6 billion years of existence, our sun has only circled the galaxy about 20 times. We are, in a very real sense, still toddlers on the galactic stage, having only completed a handful of laps around our cosmic track. Right now, as you sit still, you are actually a passenger on a high-speed chase through the void. Our solar system is surfing the galaxy at a mind-numbing 828,000 kilometers per hour. That is more than 230 kilometers every single second. Despite this blistering pace, the Milky Way is so incomprehensibly vast that we feel no wind, no friction, and no sense of movement. We are part of a silent, endless current. Even as we sleep, the Earth turns, the Moon circles, and our entire solar system sweeps forward through a galaxy that is itself in constant, fluid motion. The stars you see in the sky tonight are merely temporary neighbors. They weren't always nearby, and as the great galactic year unfolds, they will eventually drift away, replaced by new constellations in a slow-motion game of musical chairs. If we could look back to the start of our current lap, about 230 million years ago, the Earth would be unrecognizable. The last time the solar system was in this exact part of the galaxy, the supercontinent Pangaea was only just beginning to break apart. The first dinosaurs hadn't even emerged yet. Every mountain range you know, every ocean, and every fossil was formed while we were traveling through different neighborhoods of the Milky Way. It's a humbling thought. The dinosaurs didn't just live in a different time. They lived on the other side of the galaxy. When they looked up at the night sky, they saw an entirely different arrangement of stars, perhaps looking into the glowing heart of a spiral arm that we won't visit again for another 100 million years. Our journey through the galaxy isn't a simple, flat circle either. The Milky Way's rotation is famously strange and actually defies the classical predictions of Newtonian physics. In a normal solar system, the outer planets move more slowly than the inner ones, but in our galaxy, stars on the outskirts orbit almost as quickly as those near the center. This flat rotation curve is one of the greatest mysteries in science, and it's the primary reason we know dark matter must exist. Something invisible is acting like a gravitational glue, holding the galaxy together and ensuring that even as we race at hundreds of kilometers per second, we don't get flung out into the intergalactic dark like sparks from a spinning wheel. We currently reside in a relatively quiet suburban lane called the Orion Spur, tucked neatly between the much larger Sagittarius and Perseus spiral arms. It's a minor structure, but its peacefulness is likely why we are here to talk about it. In the dense, crowded highways of the major spiral arms, radiation storms are more frequent and massive stars explode as supernovas with terrifying regularity. By living in this quiet corner, our solar system has been granted the billions of years of stability needed for life to emerge, evolve, and eventually look back at the path we've traveled. We are drifters in a cosmic current, halfway through our current orbit, witnessing a heartbeat of time so slow that only the stars themselves can keep the count. If you could step outside our galaxy and look down upon it, you'd see a masterpiece of cosmic engineering, a vast, glowing pinwheel nearly 100,000 light-years across. But for the longest time, we actually had no idea what our home looked like. Because we are sitting deep inside the disk, tucked away in the suburbs, it's like trying to map the floor plan of a giant mansion while standing inside a single closet. For decades, we thought the Milky Way was a simple, neat spiral. It wasn't until we used infrared and radio telescopes to peer through the thick curtains of cosmic dust that we realized the truth. Our galaxy has a bar-shaped heart. Instead of a perfect circle at the center, there is a thick, elongated bridge of stars, a central bar that rotates slowly and acts as a gravitational engine, funneling gas and dust into the core to feed the black hole and spark new star birth. This central bar isn't the only surprise at the heart of the Milky Way. When astronomers mapped the core in 3 dimensions, they discovered that the central bulge, the mountain of stars at our center, isn't a smooth ball. It's shaped like a giant cosmic peanut. If you were to look at it from the side, it swells in the middle and narrows at the ends, almost like a twisting hourglass made of billions of suns. This strange wax shape or peanut geometry likely formed as the central bar buckled and puffed upward over eons of gravitational shifting. It's a reminder that the heart of our galaxy is a dynamic, living structure, sculpted by the accumulated rhythm of billions of stellar orbits. Radiating out from this complex heart are the famous spiral arms, the grand highways of the galaxy. For a long time, we debated how many there were. 2? 4? More? Recent observations suggest a complex mix of major arms, like the Perseus and Scutum Centaurus arms, and smaller fragmented spurs. These arms aren't solid like the blades of a fan. They are actually density waves, essentially cosmic traffic jams. As gas and dust drift into these higher density regions, they get compressed, triggering the birth of brilliant new stars that light up the arms in shades of radiant blue and silver. Stars, including our own sun, drift in and out of these patterns over millions of years, moving through the traffic as we circle the core. But the Milky Way isn't just a flat, perfect disk. It's actually warped. Like a vinyl record left out in the sun, our galaxy's edges bend upward on one side and downward on the other, creating a graceful S-shaped wave across the stars. This warp was invisible to us until we mapped the hydrogen gas that stretches far beyond the visible starlight. Some scientists believe this distortion is caused by the gravitational tug-of-war with satellite galaxies or invisible clumps of dark matter pulling on the edges of the disk. It shows us that even on a scale this massive, the galaxy is flexible, it bends, flexes, and ripples in response to the invisible forces surrounding it. Finally, if you looked even further out, you'd see that the disk is surrounded by a vast, ghostly halo. This is the galaxy's outer memory, a spherical shell containing ancient stars and over 150 globular clusters, tightly packed balls of stars that are among the oldest objects in the universe. This halo is also where the mysterious dark matter lives, acting as the invisible scaffolding that provides the extra gravity needed to keep the whole structure from flying apart. From its peanut-shaped heart to its warped edges and its ancient halo, the Milky Way is far more than just a collection of stars. It is a complex, layered, and beautifully imperfect piece of architecture floating in the void. By all the logic of classical physics, the Milky Way shouldn't even exist. If you look at the stars, gas, and dust we can see, the luminous matter, and calculate the gravitational pull it generates, the math falls apart. The outer edges of our galaxy are spinning so fast that they should be flung off into deep space, like water droplets from a spinning lawn sprinkler. Based only on the visible stuff, the Milky Way simply doesn't have enough grip to hold on to its stars. And yet, here we are, perfectly stable, drifting through a galaxy that remains unified. The only reason we haven't dissolved into a cloud of wandering, lonely suns is because of an invisible, ghostly presence that outweighs everything we can see many times over: dark matter. Dark matter is the ultimate ghost in the machine. It doesn't shine. It doesn't reflect light, and it doesn't block the stars behind it. It is completely transparent and silent to every telescope we have ever built. We only know it's there because we can see its muscles. At work, its immense gravity tugging on the visible stars and gas. In fact, if you could see the Milky Way's true form, the beautiful glowing spiral we love would look like a tiny, insignificant seed inside a colossal, invisible sphere of dark matter known as the galactic halo. This invisible scaffolding is the real structure of our home. The stars are just the decorative lights draped over it. This mystery is what led astronomers to realize that the Milky Way turns more like a solid wheel than a fluid whirlpool. According to Newton's laws, stars further from the center should move more slowly, just like the outer planets in our solar system move more leisurely than those near the sun. But in the Milky Way, stars on the very outskirts race along at nearly the same blistering speeds as those near the core. This flat rotation curve was the smoking gun for dark matter. It proved that there is a massive amount of unseen weight distributed throughout the galaxy, providing the extra gravitational glue needed to keep the outer rim in check. Even the subtle warp in our galaxy's disk, that graceful S-curve where the edges bend up and down, might be a sign of dark matter's influence. Some scientists believe that invisible clumps of dark matter, drifting like hidden icebergs in the halo, might be tugging on the edges of the Milky Way, causing the disk to ripple and flex. It's a haunting thought. Our entire world, every star we've ever named, and every planet we've ever dreamed of is being steered and shaped by a substance that we can't touch, see, or even fully define. We are passengers in a vehicle made of shadows. Without this invisible partner, the story of life on Earth would likely never have happened. Dark matter provided the original gravitational wells that allowed gas to gather and stars to form in the first place. It acts as a cosmic stabilizer, shielding us from the chaos of the intergalactic void. We don't know what it is, whether it's a new type of particle or a misunderstanding of gravity itself, but we know that we owe our existence to it. As we drift through the night, we aren't just surrounded by stars. We are cradled in the arms of the great unknown. At the very heart of the Milky Way, buried behind thick curtains of dust that no human eye can pierce, lies the galaxy's ultimate authority. It is a place where the laws of physics are pushed to their absolute breaking point, a singular point of gravity known as Sagittarius A*, pronounced a star. This is our supermassive black hole. It is more than 4 million times the mass of our Sun, yet it occupies a space smaller than the orbit of the planet Mercury. It is the invisible anchor around which our entire galactic city turns, a silent conductor pulling hundreds of billions of stars into a slow, relentless dance across the eons. For a long time, Sagittarius A* was a ghost. We couldn't see it directly because black holes, by definition, trap even light, but we knew it was there because of the chaos it caused for its neighbors. Astronomers have spent decades watching stars near the galactic center whip around an empty patch of space at incredible speeds, tracing tight, invisible loops through the void. These stars are moving at millions of miles per hour, held in place by a gravitational pull so immense that only a supermassive black hole could explain it. It was like watching a group of people dancing frantically around an invisible partner at the center of a ballroom. Today, Sagittarius A* is what we call a quiet black hole. It isn't actively devouring huge amounts of matter, which is lucky for us. Occasionally, a wandering cloud of gas or a stray asteroid drifts too close and gets shredded by tidal forces, flaring with X-rays as the material spirals into the event horizon, the point of no return. But for the most part, the giant is sleeping. However, it wasn't always this peaceful. Evidence suggests that millions of years ago, our black hole may have wakened, burning like a brilliant quasar and lighting up the entire galaxy from within. We can still see the echoes of this violent past. Towering tens of thousands of light years above and below the galactic center are two vast, ghostly lobes of high-energy light known as the Fermi bubbles. Discovered only recently, these enormous structures glow in gamma rays, extending like twin balloons from the Milky Way's heart. They are likely the remnants of a massive outburst from Sagittarius A asterisk, a cosmic burp of energy that occurred when the black hole finished a particular large meal eons ago. They serve as a haunting reminder that while our center is calm today, it possesses a power that can reshape the galaxy on a whim. Despite its terrifying reputation, Sagittarius A asterisk is essential to the Milky Way's identity. It acts as the gravitational engine that helps maintain the structure of the central bar and the inner spiral arms. It is the ultimate recycler, occasionally flinging stars out of the galaxy at millions of miles per hour, creating hypervelocity stars that roam the intergalactic dark while drawing others in to be part of the core's dense, radiant cluster. It is a place of endings, yes, but also the foundation upon which our entire home is built. The Milky Way is not a static museum of light. It is a colossal churning factory of life and death. Scattered throughout the spiral arms are vast, glowing clouds of gas and dust known as nebulae. These are the galaxy's stellar nurseries. If you were to look into a place like the Orion Nebula, you'd see towering pillars of hydrogen gas being sculpted by the radiation of nearby stars. Within these dense, cold pockets, gravity is working a slow magic. It pulls the gas together, tighter and tighter, until the pressure and heat become so intense that a spark of nuclear fusion ignites. In that instant, a star is born, pushing back the darkness with its first breath of light. These nurseries are the birthplaces of everything we know. Our own sun was born in a place just like this, surrounded by sibling stars that have since drifted away into the galactic current. However, for every star that is born, another must eventually face its end. The Milky Way is a master of recycling. When a massive star reaches the end of its life, it doesn't go quietly. It dies in a supernova, an explosion so powerful it can briefly outshine the entire galaxy. This isn't just a moment of destruction. It is the ultimate act of creation. The intense heat of a supernova is the only place in the universe where heavy elements like gold, silver, and uranium are forged. When the star explodes, it flings these precious materials across the stars, seeding the next generation of gas clouds with the ingredients for planets, mountains, and even the iron in your blood. We are quite literally made of the ash of dead stars that lived and died in the Milky Way billions of years ago. Between birth and death, stars live out incredibly diverse lives. Some, like the red dwarfs, are small, cool, and incredibly patient. They burn their fuel so slowly that they can live for trillions of years longer than the current age of the universe. These are the marathon runners of the Milky Way, and they make up the vast majority of the stars in our neighborhood. On the other end of the spectrum are the blue giants, massive, temperamental stars that burn bright and hot, living fast and dying young in just a few million years. These giants act like cosmic beacons, lighting up the spiral arms and defining the look of our galaxy for the brief time they exist. The graveyards of these stars are just as fascinating as their birthplaces. When a star like our sun dies, it doesn't explode. It gently sheds its outer layers, creating a beautiful, glowing planetary nebula that looks like a ghost of its former self. What remains is a white dwarf, a small, dense core about the size of Earth, but with the mass of a sun. These glowing embers will slowly cool over billions of years until they fade into black dwarfs. But the more massive stars leave behind stranger corpses, neutron stars, which are so dense that a single teaspoon of their material would weigh 1 billion tons, or the ultimate graveyard, a black hole, where gravity has won the battle against light itself. This endless cycle of birth, death, and rebirth is what keeps the Milky Way alive. If the galaxy ever stopped making new stars, it would eventually grow dark and cold as the old stars burned out. But for now, The factory is still running. New stars are igniting in the dark corners of the Perseus arm, and old stars are scattering the seeds of the future into the void. This constant exchange of matter and energy ensures that the Milky Way is always evolving, always changing, and always preparing the ground for the next chapter of cosmic history. If we only relied on our eyes to understand the Milky Way, we would be missing more than 90% of the story. Our vision is tuned to a tiny sliver of the electromagnetic spectrum, but the galaxy is shouting in frequencies we can't perceive. Imagine standing in a grand cathedral while wearing earplugs. You see the architecture, but you miss the music that makes the space come alive. To truly hear the symphony of our galaxy, we have to look through the eyes of radio telescopes, X-ray observatories, and gamma-ray detectors. When we do, the dark voids between the stars suddenly vanish, replaced by a chaotic glowing web of magnetic fields, superheated gas, and high-energy particles that tie the entire system together. One of the most startling discoveries of the last decade was the realization that the Milky Way is breathing out massive bubbles of energy. Known as the Fermi bubbles, these enormous structures extend 25,000 light-years above and below the galactic center. They are invisible to optical telescopes, but in gamma-ray light, they glow like two giant purple light bulbs. They are the remnants of a massive energetic event from our central black hole, a cosmic burp that occurred millions of years ago. These bubbles act as a pressure valve for the galaxy, showing us that the heart of the Milky Way isn't just a passive anchor, but a source of immense power that can push matter and energy clear out into the intergalactic void. Beyond these giant bubbles, the Milky Way is crisscrossed by a complex nervous system of magnetic fields. These fields aren't just there for decoration. They act as the invisible hands that shape the galaxy. They help funnel gas into the spiral arms to create new stars and protect the disk from being bombarded by too many cosmic rays. If you could see these magnetic lines, they would look like golden threads woven through the dust clouds, guiding the flow of matter across thousands of light years. This magnetic web is the reason the galaxy maintains its structure. It provides a subtle tension that balances the raw pulling power of gravity. Then there is the interstellar medium, the thin, ghostly fog of gas and dust that fills the space between stars. In the invisible view, this space is far from empty. It is a turbulent sea of hydrogen and helium rippled by the shock waves of distant supernovas. When a star explodes, it sends a sonic boom through this medium, compressing the gas and starting the process of star birth all over again. By looking in radio waves, we can map this gas and see how it flows like a river toward the galactic center. This hidden matter is the lifeblood of the Milky Way, the raw material that the galaxy uses to recycle itself over and over again through the eons. This invisible symphony reminds us that the Milky Way is a unified organism. The stars aren't isolated islands. They are connected by light, magnetism, and gas. Every time a black hole flares or a star is born, the ripples are felt across the spectrum. We are living inside a giant, humming machine of energy that is constantly shifting and vibrating. When you look at the dark patches of the night sky, remember that they aren't empty. They are simply filled with the light our eyes weren't designed to see, carrying the secrets of the galaxy's past and the blueprints for its future. For all its staggering size, the Milky Way is not a lonely island in the dark. It is actually part of a small, tight-knit family known as the local group. This cosmic neighborhood consists of more than 50 galaxies, most of which are tiny dwarf galaxies that act like satellite moons orbiting larger masters. In our neighborhood, there are two clear titans, the Milky Way and our slightly larger sister, the Andromeda galaxy. Together, we represent the gravitational heavyweights of this region, locking the other smaller galaxies in our orbits. It's a dynamic, interconnected system where nothing is truly still. Every member of the local group is tugging on every other member, engaged in a slow-motion gravitational tug-of-war that has lasted for billions of years. Our closest and most famous neighbors are the large and small Magellanic Clouds. If you've ever stood in the southern hemisphere on a clear night, you might have seen them, two fuzzy, glowing patches that look like detached pieces of the Milky Way. For a long time, we thought they were permanent companions, but recent data suggests they might just be passing through, making their very first close approach to our galaxy. As they zip by, the Milky Way's massive gravity is literally tearing them apart, stripping away their gas to fuel our own star formation. It's a reminder that the space between galaxies isn't a wall. It's a bridge where matter is constantly being exchanged, stolen, and repurposed. But the local group itself is just a tiny part of an even grander structure. If we zoom out even further, we find that our neighborhood is nestled inside the Virgo supercluster, which is just one branch of a colossal continent of galaxies called Laniakea, a Hawaiian name meaning immense heaven. Laniakea is a web of 100,000 galaxies stretching across 500 million light-years. In this grand map, the Milky Way is like a single house on a long street in a massive city. We are connected to these distant galaxies by invisible filaments of dark matter, cosmic highways that dictate how galaxies move and grow. We aren't just drifting. We are flowing toward a mysterious gravitational focal point known as the Great Attractor. This sense of place changes how we view ourselves. When we look at Andromeda, the only object outside our galaxy that you can see, with the naked eye, we aren't just looking at a distant light. We are looking at a mirror of our own future. Andromeda is a spiral just like us, with its own black hole, its own billion stars, and its own collection of planets. The space between us is currently 2.5 million light-years, a gap so vast it takes light itself millions of years to cross. And yet, that gap is closing. We are being pulled toward each other by an irresistible force, a reminder that in the universe, neighborhood is a temporary term. Understanding our neighborhood also helps us solve the mystery of our own missing matter. By looking at how the Milky Way interacts with its dwarf companions, astronomers can calculate the total mass of our galaxy more accurately. We see how our gravity bends their light and warps their shapes. We are a dominant force in our local corner of the universe, a ruler of a small kingdom of dwarfs. But we are also part of a much larger, beautiful web that reminds us that no matter how big the Milky Way feels, it is just one thread in a tapestry that stretches beyond the horizon of what we can see. Everything we have discussed so far, the cannibalized galaxies of our past, the steady rotation of our spiral arms, and the quiet suburban life of our sun is leading toward a singular, inevitable climax. We often think of the universe as a place of eternal expansion where things only move further apart, but on a local scale, gravity is a master of reunions. Right now, the Milky Way and its massive neighbor Andromeda are falling toward each other at about 250,000 miles per hour. While 4.5 billion years seems like an eternity in human terms, in the life of a galaxy, it is the blink of an eye. We are living in the final era of the Milky Way as we know it. The final merger isn't just an end. It is a metamorphosis that will create something entirely new. If you could stand on Earth 4 billion years from now, the night sky would be terrifyingly beautiful. Andromeda, which today is just a faint smudge of light, would grow until it filled the entire horizon, a second, massive wheel of fire pressing down upon us. As the two galaxies begin their first close pass, the gravitational tides will be so immense they will physically warp the disks. Huge streamers of gas and stars will be flung out into the intergalactic void, creating tidal tails hundreds of thousands of light-years long. The nice, orderly spiral arms we see today will be shredded, twisted into a chaotic dance as the two supermassive black holes at our centers begin to spiral toward one another. A common fear when imagining this collision is the crash. We think of billions of stars smashing into each other like cars in a pileup, but space is shockingly empty. The distance between stars is so vast that the odds of any two suns actually physically colliding are practically zero. Instead, the collision is more like two swarms of bees passing through one another. The real action happens in the gas clouds. When the vast reservoirs of hydrogen from both galaxies slam together, they will trigger a starburst event, a frantic, brilliant explosion of new star birth that will light up the merging system like a cosmic Christmas tree. For a few million years, our neighborhood will be the brightest spot in the local universe. Eventually, the chaos will settle. After a few billion years of swinging back and forth, the two galaxies will settle into a single massive home. Astronomers have already given it a name, Milky. This new galaxy won't be a spiral. The delicate structure of the arms will be lost, replaced by a giant, glowing, elliptical galaxy, a smooth, featureless ball of trillions of stars. Our Sun, if it survives its own evolution, will likely be kicked out into a much wider orbit, far from the new, dense center. The night sky will no longer have a Milky Way band across it. Instead, it will be a uniform glow of ancient stars stretching in every direction. This merger represents the final chapter of our galaxy's biography. It is the moment when the cannibal finally meets its match and finds a partner. It's a poetic conclusion to a 13 billion year journey, a reminder that in the cosmos, nothing is truly lost, only transformed. We began as a chaotic cloud of gas, grew into a majestic spiral of light, and we will end as part of a celestial titan. As you look up at the stars tonight, remember that you are witnessing a masterpiece in progress. We aren't just living in a galaxy. We are part of a living, breathing, and ever-changing story that is still being written across the dark.